Statistics is all about collecting data and recording variables and then using those to try and make generalizations about a population. So let's start with talking about what is a variable. A variable is a recorded piece of information or a characteristic about a person, a case, or unit in our study. So variables are some characteristic or info that's recorded for each person, but it varies or changes from person to person. So for example, we might record the age of everyone in our sample. And for everyone we're recording the age, but the age is going to change or vary from person to person. So this is kind of the opposite of a constant, which is always the same. For the sake of our discussion, we have a few examples here that we're going to talk about. So we might record the age, the weight, BMI, does someone have a disease, yes or no, biological sex, country of birth, and so on. The way we approach summarizing and analyzing data depends largely on the type of variables that we have. Variables fall into one of two broad categories. Right? We can think of something like country of birth as placing people into categories. Something like age or weight are numerical or recorded quantities. So let's define those. The first type of variable we can call categorical, and this also sometimes gets called qualitative. So this places people into categories, or it records qualities about them. The other type of variable often gets labeled as numeric, or we can also call this quantitative. It records quantities. So let's just write some of that down. Categorical variables place people, okay, or units if we're not recording data about people, into groups or categories. Numeric are recorded numeric quantities. Again, for each person or each case. There's all those other names that get used for these as well. Through this set of videos, I'm going to refer to variable types as categorical or numeric, and I'm going to abbreviate them with cat or num. Before we go through and place some of these variables into these different variable types, let's talk about how these can be further broken down. So categorical variables can be further broken down into what we call nominal or ordinal. And numeric variables can be further broken down into discrete, so I'm just going to summarize that, DISC, or continuous. Again, I'll just abbreviate that, CONT. Okay, so let's talk about each of these. Categorical variables, things like biological sex, right, male or female, country of birth, these sorts of things. Nominal means that there is no ordering based on magnitude or size. Right, so country of birth, there's no, you can order them alphabetically, but there's no smallest to largest ordering. Where if you think of something like the size of coffee that someone orders, right, that's categorical. It can be small, medium, or large, but there is a ordering based on the size or magnitude, right? Small is smaller than medium. Medium is smaller than large, right? So there is an ordering or a ranking to these categories. So that's what we call ordinal. Right? There is a rank or an ordering to the categories. Discrete and continuous, it's a bit more of a gray area between these two, and they're often treated the same or very similarly in analysis. But discrete variables tend to take on integer only. So things like take on a value of 0, 1, 2, 3, 4. In theory, they can go all the way up to infinity, but integer only. So things like the number of people who are in an emergency room. Right? There's 0 or 1 or 2. Continuous variables, these are measured on a continuous scale. So when we record someone's weight, say, we often report weights to the nearest pound or nearest kilogram, but they're actually measured on a continuous scale, right? Your weight can be 57.258 kilograms, for example. So what we're going to do now is go through and take this list of variables and decide whether they're categorical or numeric, as well as which kind of scale of measurement has been used. And you might want to take a moment to pause the video and try and do this yourself before looking at me do this. Okay, so let's go through and place each of these variables and into which type we think they are. So age, right, is a recorded quantity, and it's continuous. Again, while we report our age to the nearest whole number, right, no one ever says that they're 35.738 years old, but it actually is measured on a continuous scale. Now thinking about weight, again, that's a numeric measurement and it's on a continuous scale. What else? Disease recorded as yes or no. That's categorical, right? We're placing someone into categories, and there's no ordering or rank to these. Biological sex, right? Again, recorded as male or female. That's a nominal categorical variable. Country of birth. I'll just shorten it, right? Country here, just for the sake of space. Hair color, again, right? It's categorical. It's nominal. Right? No natural ordering to these. Again, you can order them alphabetically, but we're talking about a ranking based on size or magnitude. Income, right? Again, that's a continuous variable. What else do we have? The number of people in the emergency room, right? Or again, number of people maybe at a moment in time, or a number of people that show up in a day. Right? This is a quantity or a numeric variable, and it's discrete. Right? It's going to be 0 or 1 or 2 or 3. In theory, it can go up to infinity. The number of live births in a day in a hospital, again, that's discrete. The size of coffee that you buy, small, medium, or large, right? That's a categorical variable, and there is an ordering or ranking to these. And finally, temperature recorded in degrees Celsius or degrees Fahrenheit, doesn't matter. Right? That's a numeric quantity, and again, measured on a continuous scale. Degrees Celsius, or you could put it as degrees Fahrenheit, doesn't really matter. Now, a few important things to note before we continue on. The first is that categorical variables sometimes are recorded using numbers, but that doesn't make them numeric. So quite often with things like, does someone have a disease, yes or no, they often get recorded with zeros and ones, one often indicating yes they do, 0 they don't. Or biological sex, right, male and female. We might record males with 0, females with 1, but again, these are not numeric variables, we're just using numbers to record them. Another good example is the Likert scale. So again, this is where we ask people, do you strongly disagree, disagree, neutral, agree, strongly agree? And we often ask them to rank it using 1, 2, 3, 4, or 5. So there, we're using numbers to indicate categories, right? Levels of agreement or disagreement. And so there we're looking at an ordinal variable. Strongly disagree, and then a little bit higher than that is disagreeing, then a bit higher is neutral, then higher is agree, then higher is strongly agree. Right? So there's a ranking or ordering to those, but the numbers don't actually mean anything other than being labels for these categories. Another example we can look at is, suppose we all decide to go and do a 10-kilometer race together. So we can record how long did it take us to finish the race, right? And this variable is a numeric measurement, right? We're recording how many minutes and seconds did it take us to run 10 kilometers. So that's a continuous variable. So I'm going to add that in here, the race time, right? Again, how many minutes and seconds did it take you to finish the race? If we make it competitive and look at who finished in first, who finished in second, who finished in third, and so on, right? Now we're looking at categories. Right? We're looking at the place that people finished, and there is a ranking to these. First place was the fastest. Second was the next fastest. Third was the next fastest. So here, the place that someone finishes in a race is a categorical variable, and it's ordinal, right? There's a ranking to them. And so again, a feature of ordinal variables is while the categories can be ordered or ranked, the spacing between them is not necessarily equal, right? The distance between first and second place isn't necessarily the same as the distance between second and third, or the distance between third and fourth, and so on. Right? So these are rank variables or ordinal variables. So as we mentioned before, the sorts of plots that we make, the summaries or the method of analysis, depends largely on, are we working with categorical variables, numeric, or what combination of categorical and numeric? Okay, so it's important to make this distinction now. A quick mention, categorical variables often get summarized using proportions or percentages. So if we're looking at, let's just say biological sex, we often summarize that by looking at how many males and how many females, or what percentage of males and percentage of females were there. Numeric variables, if we're looking at, say, something like age, we often summarize that using the mean or average age, or the median age. Okay, so in following videos, we start to talk about appropriate summaries for categorical or numeric variables, appropriate methods of analysis, and so on. Now, one more important note, and this really becomes a little bit more important further down the line, but we're going to mention it now mostly for the sake of completeness. Discrete or continuous variables can be further subdivided into scales of measurement, looking at the ratio scale or the interval scale. Okay, so let's quickly mention what those are. So the ratio scale has a meaningful zero, okay, or a meaningful ratio. And what that means is if we look at these variables here, age, weight, income, they're measured on a ratio scale, right? Meaning an age of 0 is, that 0 means something, right? There is no age. Or a weight of 0, there is no weight. Or another way to think of it, a ratio is meaningful. Someone who's 20 years old is twice as old as a 10-year-old. Someone who's 30 is twice as old as a 15-year-old. So that ratio makes sense. Things like temperature, okay, measured on degrees Celsius or degrees Fahrenheit, are measured on what we call an interval scale. And this has a non-meaningful, okay, or an arbitrary 0. Okay, and again, what we mean by that is a temperature of 0 degrees Celsius or 0 degrees Fahrenheit doesn't mean there's an absence of temperature. Or they do not have a meaningful ratio. 20 degrees is not twice as hot as 10 degrees. Right? 30 degrees is not twice as hot as 15 degrees. Right? This is a scale, okay, but the 0 is not an absence. Okay? The ratio is not meaningful. Now, just a few other important notes for us to talk about before we wrap this up. The first is identifiers. So often there's identifiers that are used, things like your student number or an employee ID, things like these. These are used to identify an individual, but they're not variables. Okay? They sometimes fit in this conversation in that they're often one of the columns in your data set, but they're really used to identify an individual. They're not a true variable. Another important note is that you can always convert numeric variables into categorical variables. Okay, so for example, we can take something like age, and rather than using numeric age, we can convert that or break it down into, say, child, adult, and say senior. Or we might just break it into age categories of 0 to 10, 10 to 20, 20 to 30, and so on. And then I guess one final note to mention that we've already said, but I'm going to write it down here, is that sometimes categorical variables are recorded using numbers. This doesn't mean that they're numeric variables, but we often use numbers as placeholders for the categories. So in the following videos, we start to explore how to summarize variables graphically and numerically, depending on whether they're categorical or numeric. And then the methods of analysis we build up, again, really focus on what type of variable or variables do we have.
Stick around, guys, because we got lots more. Statistics is so much fun. My dad is a statistics ninja.